Yeah, now we're recording. Alright, so we're looking at the absolute value today, so we're going to apply these to the equation and we'll go from there. So, the first question, absolute value of x is equal to 4. So what value of x, that when I take the absolute value of it and it gives me 4? Okay, so x is going to be plus or minus, that's the notation, universal. Alright, so that means we're taking both the positive and the negative notion of that number. And then it asks you to graph on a number line. Everyone now has their rulers, don't they?
Yeah, we do.
Everyone has their rulers, don't they?
I have a ruler.
I have a straight line.
Straight line will do. Credit card or something like that. Okay, so alright, so number lines representing all the positioning of all our numbers that we know of, except for complex numbers, and we'll only look at that in extension 2 if anyone here dares go down that road.
Complex numbers.
Alright.
What do you mean? Let's do it. What do you mean? Are they numbers that go like up?
There will be a requirement to get into extension 2, don't you worry about that. Alright, so I'm going to put 0 in the middle, 4 on the right, negative 4 on the left. Okay, making sure they're equal distance from the origin. Okay, don't make one 4 closer, don't make one of the 4 or negative 4s closer than the other. Okay, keep it consistent. Alright, so we have an equals. So what we need to do is on the number line, we have a filled in circle on both those values. So we looked at inequalities. So when we have just the dot, it means it's only just those numbers that satisfy the condition above. Okay. B. Right, the absolute value of x is greater than or equal to 4. Right, so we need to look at the possible solution that suits that condition. So we've already looked at the definition, so we take the absolute value of a positive number, we get a positive number again, the same number, and then we take the absolute value of a negative number, we're going to get the positive equivalent of that. Okay, so what this means, so we have the value of x, which will be greater than or equal to 4. Okay, and we also have the value for x, which is greater than or equal to negative 4. Alright, considering both those cases. Hang on, sorry, back to front, do it again. Negative x, which is greater than or equal to 4. So we want to take the absolute value of that negative sign, and the result will be less than, greater than or equal to 4. So this is fine, so that's finished. However, we want x by itself. Alright, so I'm multiplying by -1. So I'll do the same to both sides. And remember our inequality rules. When you multiply or divide by a negative number, you need to reverse the sign of the inequality. So x will be less than or equal to negative 4. Okay, so if we take a number that's greater than or equal to 4, let's say 10, so is the absolute value of 10 greater than or equal to 4? Yes. Take a number that's less than or equal to negative 4. So I go in the negative direction. I'll go negative 6. The absolute value of negative 6, which is 6, is it greater than or equal to 4? Yes. Okay. If I take a solution somewhere in between, okay, let's say 2, because it's not greater than 4, it's not less than negative 4. The absolute value of 2, which is 2, which is certainly not greater than or equal to 4. Alright, so that will be the reason why we set it up this way. Alright, number 1, 4 and negative 4. It's okay, so it's central at 0, negative 4 there, negative 4 there. Alright, make sure arrowheads are on the end because a number line is a representation of an infinite number of numbers. And we're referring to these numbers as the x numbers. You need a ruler. You need a ruler. Can you organise? Actually, Amanda, I will give you a ruler today. I will give you a ruler today. Can't say I don't help you, eh? Alright, so we central at 0. Okay, so we've got 4 and we've got negative 4. So now we need to consider the solution. So x is greater than or equal to 4. So we have a closed circle because there's also an equal component to there. And there's going to be a ray. The ray has a definite starting point but no end point going to the direction of the inequality there. And the second one, x is less than or equal. So again, we have a closing circle to show the equal component, and then the inequality requires us to have the ray pointing to the left. Alright, and that's how we graph our solution. So any number between 4 and negative 4, not including those two numbers, will not suit the definition up here, and that's what the graph will tell me. Okay, question. Right, everyone done? Alright, so moving on. So C. Right, so this is just equation, no number line. So x, so the absolute value of x is 7. So very similar to what we had at the start. So we're showing you graphically the first couple of questions. We're now going to do them algebraically. Okay, which is pretty much what I've done already. Alright, so what number, when we take the absolute value of it, gives me 7. Okay, x equals plus or minus 7. Okay, so positive 7, I can also have the negative 7 there as well. D. Right, x. Take away 5 is equal to 12. Okay, so similar to what I've done up here, I had to make the number on the right hand side both positive and negative, so that is how I'm going to set up my work. So x take away 5 must equal the positive component there, which is 12, and x take away 5 must equal the negative component, negative 12. So there are two possible solutions in most cases of absolute values. Okay, so there's simple equations now. Should be able to tell me straight away what the answers are for both of them. So x must equal 17 and x must equal negative 12 plus 5, which is negative 7. Okay, so those two solutions will suit that value there. So, let's justify it. Let's call this equation 1. Okay, so we're labelling equations when we want to refer back to them. Alright, so x equals 17 into equation 1. Let's sub that in and show that it's a true equation. So, the absolute value of 17, take away 5, is 12, so we're rewriting this top equation with the value replacing for x. So we did 17 take away 5, which is 12, take the absolute value, and we have 12. Okay, so that's the whole point of solving that equation. Any equation, finding the values of the variable, that makes the equation true. Okay, so that one works. Right, x equals -7. Let's put that into the equation now. So the absolute value of -7 take away 5 is equal to 12. So I've rewritten the equation again, replacing the value for x. So -7 take away 5 should end up at -12. Alright, so when we take the absolute value of -12, we get 12. So 12. Okay, so that is why there are two possible solutions. Alright, you've got to consider both the positive and the negative in there. Alright, 2x. So the absolute value of 2x is equal to 9 take away x. Alright, so whenever you see an absolute value equation, you need to consider two possible solutions. Okay? So you need to consider what happens when inside this bracket the absolute value sign is positive. You also need to consider what happens inside this sign, the absolute value sign is negative. Okay? So the way to do that, we set up two equations. So 2x equals 9 take away x. And we also need to consider 2x is equal to negative 9 take away x. Okay, now the bracket needs to be there because I need this whole expression to be the negative of the positive component. You can also put it out the front of the 2x if you wish, right? As long as one of the sides on the equation, everything's negative, okay? Or change to a negative component. Right, so let's solve. So we need to move any variables on the right-hand side over to the left-hand side by doing the opposite operation. Okay, it's almost a three-step equation. So I need all my variables on the left-hand side. So my 3x will equal 9. And then of course I'll divide both sides by 3.
So why don't you yeah, why not?
Kyle, not relevant right now. So that's that solution. So x equals 3 will satisfy the equation here. Not relevant now, boys. Right, the next one. So 2x equals negative outside of 9 take away x. So let's expand the negative. So 2x, negative 1, this is how it is. Negative 1 times 9, which is negative 9. And then a negative 1 times the negative x. The negative times the negative gives a positive. So we have a positive x. The other way to see it is, of course, you change the sign, what's happening inside that bracket. Okay, so move the variable over to the left by doing the opposite. So you're doing a take away x on both sides. So 2x take away x, which is x. And then we're just left with the minus 9. Okay, so they're my solutions there. So now, this is where you will need to. Because just because you have two solutions there doesn't necessarily mean that they will work. Okay? Now, if you notice back up to the example here, when it's a constant number on the right-hand side or the left-hand side, when it's just a constant number, the two solutions should work every time. Okay? I haven't met a situation where it won't. when you have a variable on both sides, okay, you actually need to go through and check the solution to make sure it satisfies the original equation, okay? So, equation 1. So I want to substitute these two into equation 1. Right, so let's do this side. So we need to substitute 3 for every time we have an x. So the absolute value of 2 lots of 3, or you can do 2 times 3 if you wish, is equal to 9 take away 3. So every time there's an x, I've replaced it with 3. Right, so I've got 2 times 3, which is 6. Take the absolute value of 6, and I'll get 6 again. And then 9 take away 3, which is 6. Right, so that solution works. So, the next one, negative 9. We need to substitute negative 9 for x into the equation there. So 2 outside of negative 9, so this is a multiplication, it is not a subtraction. This is 2x, 2 times x, 2 times negative 9. Equals 9 take away negative 9, okay? You need to add the sign as well. So that, 2 times minus 9, so positive times the negative gives us a negative. 2 times 9 gives us 18. So the absolute value of negative 18. 2 negatives here make a positive. So 9 plus 9, which is 18. Okay? So 18 equals 18. Right? So that particular solution does work. Right, let's conclude. Therefore, x must be 3, and it can also equal negative 9. Okay, any questions? About to step it up, so if you have any questions you're not understanding, you need to be asking now before we go up to the next stage.
Stop! I've already mentally disturbed enough as it is.
Right, the absolute value of 4x take away 1. Whoop. Okay, make sure the absolute value that's in a straight line is equal to, let's do 2x plus 7. Right, in your notes, it has an absolute value sign there as well. I don't want the absolute values on the other side. So on page 18, F, if you've got your notes there, can you cross out the absolute value on the right hand side? Page 18. Okay, it's a three-step equation, but before that, you have to set it up and you'll have 2 lots of three-step equations to solve. Right, so 4x take away 1 must equal the positive side, so 2x plus 7. And we have 4x take away 1 is also equal to the negative component, 2x plus 7. So put the minus sign, grouping symbols, because I need to consider the negative side as well. Okay, let's solve our three-step equation.
Minus 2x
Alright, so let's solve. So move the variable over to the left. I know I'm changing colours a lot. You don't have to do that. Alright, it's just to illustrate the steps. Right, but to show you the working, I'll always start using the same colour again anyway. Right, so 4x take away 2x, which is 2x. We still have the negative 1 there. We've eliminated the 2x on the right hand side by moving over to the left hand side, but we still have the positive 7 on that side. Okay, step number 1's done. Step number 2. Right, numbers, move to the right hand side. We're doing the opposite operation. The 7 plus 1, which is 8. So x must be 4. Right, so before we can solve on the right hand side, we need to expand it. Or in other words, we change the sign to the opposite sign. Alright, I'm not going to keep changing colour. And we get negative 1 as our solution for that particular equation. Right, so just lay with the original equation, equation 1. And I want to substitute both these answers because there's the variable on both sides. Okay? When you have the variable on both sides, you must substitute your answers in there because there will be times when one or both of these answers will not be valid. Okay? So you need to do this. You will not get your full mark if you stop here. You need to show evidence of substitution and showing either one, both of them, or neither of them works. Alright, so the absolute value of 4 lots of 4, take away 1, is equal to 2 lots of 4 plus 7. Okay, so replace x's with 4, and then I'm going to evaluate. So 4 times 4, which is 16, take away 1, which is 15, take the absolute value, and I'll get 15. And on the right hand side, I've got 2 times 4, which is 8, plus 7. 8 plus 7 is also 15. Okay, that will mean that this particular solution works.
So not both of them don't have to work.
Yeah. Okay, and that's why we need to check. Why are you worried? Hey?
I'm pretty sure I did something wrong in my second equation because I did not get an answer.
Say it again, sorry.
No, worries, just keep going.
Keep going. Alright, so the absolute value of 4 lots of negative 1, take away 1, is equal to 2 lots of negative 1 plus 7. So I've rewrote the equation, replacing x's with negative 1, and be careful with substitution by putting brackets in there. Alright, so 4 lots of negative 1, which is negative 4. Negative 4, take away 1, which is negative 5. Take the absolute value of negative 5, and you get 5. So 2 times negative 1, which is 2. Negative 2, so negative 2 plus 7, it will give you 5. Okay, so this one also works. So this is an example where both those solutions will work. There will be some that won't work. I was hopeful it would be this one, not the case. Alright, so after you've done your test, conclude. So therefore, it's the 3 dots in a triangle pattern. So x must equal 4 and x can also equal -1. Okay, there will be times where you will not have both solutions working. Okay, so if that's the case, we say no, it doesn't work, and we state the other value if it works, or we don't state anything. We say there is no solution if neither of them work. Right, a couple more. Right, G. So the absolute value of x, take away 2, is greater than 9. Okay, so now we've got inequalities. So we solve them the same way as we do our equation. We just got to remember when we divide or multiply by a negative number, we need to swap the sign. Right, so we set it up first. So x take away 2 is greater than 9. The other one you need to consider, x take away 2 is greater than -9. I'm not sure about the marking allocation, but maybe there's a chance that just stating that you might get your first mark. There's a chance, okay? So make sure you're stating the possible solution. Right, so add 2 to both sides in this the inequality here. X must be greater than 11. Alright, add 2 to both sides here. So x is greater than -7. Alright, so if you want to get in good habit and checking your solutions, okay, I suggest you do so. But I'm telling you, alright, because it's just a number on the right hand side, alright, both solutions will work. Okay? However, if you are not comfortable with that, you need to go through the testing process and check both those solutions suits the original inequality there, and then state the final values at the end. Okay? So I won't do that because I want to focus on the next one. So we've got the absolute value of x plus 1, which is less than or equal to 2x. No, that won't work. Alright, can we just stop that one for a moment? Alright, so, did anyone actually notice anything, what I noticed?
-7, -9 is not greater than 9.
So x has got to be greater than -7, so -6 for example, which is greater than -7. So -6 take away 2, which is -8, which is not greater than 9. What do we do? Okay, so what I want you to do is just do a quick sketch of a number line. Okay, I'm not marking you on this, so you can be as rough as you want. Alright, critical points. Let's go. -7, 11. Okay, put them roughly where they would be, obviously in comparison to each other. When you have an inequality, you will need to check a point in each of the 3 regions, okay? So, you will need to check a point in this region, You will check a point in this region. You will also check a point in that region. Alright, 3 different regions to test. So, it's right under here, test. Right, so what's the number that is less than -7? Right, so -8. Let's put it into equation 1. Right, so the absolute value of -8 take away 2, we want to see if it's greater than 9. Okay? So, the absolute value is -8 take away 2, which is -10, is greater than 9. Okay, so 10 is greater than 9. Okay, what that means is any point less than -7 will work. Okay, in that region, the point will work. Alright, so let's check a point between -7 and 11. What's the better point than -2?
0.
Don't make life so difficult if you do not need to. X equals 0. So we're checking a point between -7 and 11. Pick simple numbers to work with. Don't pick anything that requires you more than something else. Okay, let's put that into equation 1. So the absolute value of 0 minus 2 is greater than 9. Okay, so 0 minus 2, -2, absolute value -2, which is 2. Is the number 2 greater than 9? No. Okay, so this is an example where the solutions won't work. Okay, that means in here, in this region, no point between those two will work. Even though I have said over here with the math that any solution greater than -7 will work. Okay, and it won't. So that is why you need to check it. Okay? Right, so last one, we need to pick a point in that region. 12? Right, so test x is 12 into equation 1. So the absolute value of 12, take away 2, is it greater than 9?
Yes.
Alright, so 12 take away 2, which is 10. The absolute value of 10 is greater than 9. Okay, so that means the point work in this region. So, what is my final solution though? How do I write it?
Small x equals small.
Isn't x is greater than 11 smaller than -7?
Good. Okay, so x is less than -7. We want any point to the left, any point less than -7. Okay, because the number itself gets bigger, but with a minus sign out the front. Right, so it will work. X can also be greater. So on the right of 11 works, so x can be greater than 11. Okay, so when you have an inequality, you need to get the critical point by doing the math, and then you need to check the region bounded by those critical points. Extension students, you're going to have to step this up the next step later on in the term. Next term. You'll have fractions with the variable on the bottom. Oscar fun.
You said that about everything. You said that about polynomials.
Hey?
You said the polynomials.
It depends on what side of the maths things you like.
You said the circle.
I've been telling you I really love circle geometry. Some people might really absolutely hate it with a passion. Okay, last one. H. Alright, the absolute value of x plus 1 is less than or equal to 2x. Okay, so absolute value and inequality means you need to check the region bounded by your solution. So let's set it up. X plus 1 is less than or equal to 2x. X plus 1 is less than or equal to negative 2x. Okay, you've got to set the positive and the negative on either side of the inequality. Right, so we need to move this over. Negative 2x. So negative x plus 1 is less than or equal to 0. The sign doesn't change. This is a subtraction. This is not a multiplication or division. Okay? Right, take away 1 on both sides. So negative x is less than or equal to negative 1. Again, we are subtracting. We are not multiplying or dividing, so the sign stays there. However, the next step, we are dividing by a negative 1. So x can be greater than or equal to 1. You miss something?
No, it wasn't wrong. It just took less steps.
Yeah, I wish your homework would see the same as this, eh? Okay, so keep in mind those people who are doing their homework and are only writing answers or minimal steps, I don't do this here, okay? Alright, let's add 2x. Add 2x, so 3x plus 1 is less than or equal to 0. Take away 1 on both sides. 3x is less than or equal to negative 1. Divide both sides by 3. X is less than or equal to negative a third. Alright, inequality, absolute value. Check your region. Next. Okay, so just a rough sketch. Plotting these critical points in respect to each other. So obviously 1 is going to be on the right of negative a third. Okay, so I'm going to do something like this. What I need to do is check these 3 regions that's formed by those critical points. Alright, so label it. Back to the question. That's what we're referencing. We're going to not that, sorry. Alright, so test. Alright, let's work from left to right. What's the number less than negative a third?
Negative 20.
Wow, Robin's been very adventurous today. Negative 20. Alright, so let's put that into equation 1. So equation 1, the absolute value of x plus 1 is less than or equal to 2x. The absolute value of negative 20 plus 1 is less than or equal to 2 lots of negative 20. Okay, so replace the x with our test here. Okay, negative 20 plus 1, which is negative 19. Take the absolute value of negative 19. 19. And then you've got 2 lots of negative 20 on the right hand side. Negative 40. Okay, so is 19 less than or equal to negative 40? Okay, so that means this region will not satisfy the original inequality, any point within that region. Okay, between negative a third and 1. Alright, x equals 0 into 1. Alright, so the absolute value of 0 plus 1 is it less than or equal to 2 lots of 0? Is 1 less than or equal to 0? No, so that one also does not work. Now, also keeping in mind, the original equation has greater than or equal to, less than or equal to. Do not check the points that are there, okay? Because it's always going to be true, right? But you've got to see what's happening on either side. Make sure you pick your point away from those critical points. Right, so x equals
Can
what?
we do 5,250?
So?
5,250. Let's do it.
I should turn the camera around and everyone can witness me just slapping you across the head. Alright, let's do 2.
Oh.
Like I said, don't make the math more difficult than what it needs to be. X equals 2, so the absolute value of 2 plus 1, is it less than or equal to 2 lots of 2? So 3, which is less than or equal to 4, yes. Alright, so it has to be that all solutions greater than or equal to 1 will work for this particular question. So you need to conclude that therefore x is greater than or equal to 1 will satisfy the original inequality. Perfect timing. Alright, so period 6 today, we'll be back. Alright, that is your working lesson. I will see you later.